In the last video, we defined molarity as moles of solute per liter of solution. Alright, the solute is anything that's dissolved in the solution. Now, this is a conversion factor because it's a fraction and it relates liters of solution to moles of solute. So anytime you've got some kind of a roadmap and a conversion problem that has an amount of solute that you want to link with a volume of solution, the critical link in a problem like this is the molarity. A lot of the problems that are on the worksheet are just unit conversion problems that have you recognize this. Let's do an example. Suppose I want to know, I've got 10.0 grams of NaCl, and I want to make 0.030 molar NaCl from that. If I want to use up all the salt that I've got to make this, how many milliliters do I have to dilute the 10 grams of NaCl to? So picture it, you got a pile of NaCl. You want to know how much water do you need to add to that in order to get a solution with that concentration. Alright, this is really, all of these are just unit conversion problems. Let's pick out what our target is. How many milliliters? So I'm trying to get to milliliters. That is not a fraction, so I want to start with something that's not a fraction. Now when I look at the two numbers that I have to work with, 10 grams and 0.030 molar, this one is really a fraction. Anytime you see the capital M in a problem, you can cross it out and replace it with moles of whatever that is per liter of solution. So that's a fraction. And you don't want to start a conversion into something that's not a fraction with a fraction. You want to use this. This is not a fraction. It has the same shape as where you're going. Now I got to connect an amount of solute to the volume of solution. And the critical link is going to be a molarity. Because anytime you're trying to do a job like that, convert solute into volume of solution, the molarity is the link you need. So let's drop this link in here. Let's drop liters close to milliliters, and let's drop moles of solute, which is the NaCl, close to the grams. And our strategy is going to be then to do this. Now, to go from moles of NaCl to liters, we're going to use the molarity. To go from liters to milliliters, we can do that. We've done it a lot. We know our prefixes. Milli means 10 to the minus 3. And to go from grams to moles, I always need a molar mass. So I'm going to need the molar mass of this, and it's roughly 58.5 grams of NaCl in 1 mole of NaCl. So now I have my 3 conversion factors. I can go from this to this, this to this, this to this, and get it done. So let's set up the problem. I'm going to write down my starting point again. And I know in the first conversion factor I got to have grams of NaCl on the bottom to cancel that out. Here's my first conversion factor. There's a 58.5 sitting next to the grams of NaCl. And then on the other side I have the 1 mole NaCl. That's how I figured out what goes on top and what goes on the bottom. You got to write the units in or you can't. you can't figure it out. You can't figure out what's on top and what's on bottom. Now this is on top, so I want to get rid of that in the next one. So it has to go in the bottom of the next one. If I look at my next link, there's a 0.030 sitting next to that, and there's a 1 liter on top. That'll get rid of the moles of NaCl. I've got liters on top, but I want milliliters in the end. So I know liters has to go in the bottom. 10 to the minus 3 liters is 1 milliliter. So now it's just a matter of doing the math. 10 divided by 58.5 divided by 0.030 divided by 1 EE minus 3 would give you your answer. How many significant figures should your answer have? This has 3, this has 3, this has 2. 2 significant figures there. Remember, leading zeros are not significant. And this is exact, so you're going to round your answer off to this, to 2 figures. The problems in the worksheet will expect you to be mindful of significant figures.